Okay, it is time to draw our storm model. So let's set it up and let's first get some land in here and some water. And as we draw, we'll talk a little bit about what's going on. So throughout the day, anywhere that there was water and the sun was shining, the thermal energy, the light energy was turning into thermal energy at the surface of the earth. So any surface, whether it was the land, the water, rocks, concrete, buildings, doesn't matter, is turning into thermal energy. Now, water, when it gets enough thermal energy, then this liquid water will then turn into water droplets and fill the air with moisture. And this process is called evaporation. So this is what creates humidity in the air. Now, we talked about stable and unstable air masses. So let's go ahead and draw what would be, let's say, like a warm air mass. Let's go ahead and draw this, kind of like this. And then we have the cold air mass. It's kind of pushing underneath like this. And we learned that where these two meet, that this is the front. So if we talk about the example that you heard in the video, then we said that let's see what we say the temperatures were. So on this side, the temperatures were, or the temperature-ish was 62 degrees with humidity at about 50%. And then on the opposite side, then we have this air mass over here that was, I think we said was 80 degrees and had about 87% humidity. So a huge difference between the two air masses. Now, in general, we're going to go ahead and we're going to draw some molecules in here, just an example. So throughout this air mass, the molecules are closer together and they have a few, I don't know, I'm going to draw squares as just, I don't know, water vapor. Okay, a little bit of water vapor. Then over here, the air is further apart and it has more water vapor than the opposite side. So if this side has 5, I'm going to draw a few more than over here. 5, 6, 7, 8. Okay. So the molecules are more spread out and there's more water vapor in the air. So now what happens? So here these two are coming together, they're clashing, and now they are fighting. Like I gave you the example, when two people have differing opinions, then they tend to take longer to come to an agreement and they might have a more heated kind of discussion. So what's going on here is that this air, this cold air, wants to go under and stay to the bottom because that's the nature of what cold air wants to do, because it is more dense and pushing down on Earth's surface. So you can go ahead and draw an arrow going down. All right. Which causes this less dense air over here to begin rising. Now, this also causes the process of the water vapor condensing onto those pieces of dust and dirt and debris and pollution that are in the air. This causes clouds to form. Now, what's different about this cold front and severe storm compared to more stable air that might bring some lighter rain showers is that this is being forced up very quickly. So we're going to draw a big arrow and we're going to say lift. So this air along the front is being lifted up very quickly. All right. And so this lifting is causing this area to be very unstable. And this unstable area is forming clouds very quickly. And we said that when clouds form, that the energy is not lost, but rather it is transferred to the atmosphere. So at the same time that the warm air is pushing up, it is also giving off thermal energy into the atmosphere. Now this also allows more cloud formation. So these clouds just keep building and building and building until the rain starts to fall. So now I've got rain that's falling. All right, now notice it's just along the front. All right. All right, let's go ahead and label these pressure areas that we talked about. So over here, we know that when air is pushing down on Earth's surface, that it's creating areas of high pressure. And when air is lifting off the ground, then there is less pressure. So this is a low pressure area and a high pressure area over here. So high pressure where it's cold, low pressure where it's warm, because this is lifting up and not pressing as hard on the Earth's surface, and this one is coming down quickly and pressing on the Earth's surface, and therefore it is high pressure. Okay, don't want the video to get too long, so I think I'm going to stop there. Those are all the ingredients that it takes for a storm to form. We have moisture in the air, we have lift, we have unstable air masses, and we have energy from the sun that's been created throughout the day on the earth and transferred to the atmosphere, and then the energy that is being given off when clouds are forming. Okay, hope this helps you understand a little bit more about how storms form.